During this session, I'm going to show you how to download Integrated Architecture Builder. So first we'll bring up a web browser and go to a search engine and type in Integrated Architecture Builder. It should be the first search result that you see. So click on this. And Rockwell has a dedicated Integrated Architecture Builder website. And here we'll go to Product Selection Toolbox. Again, Product Selection Toolbox is a suite name Rockwell is using for a group of different configuration tools. Integrated Architecture Builder is one of those. So this is what we want to download. Once you click the download link, Rockwell simply wants you to fill out some information, and then when you hit submit at the bottom, a link to download the software will be provided. During this session, I wanted to share with you some of the things that are included on the Integrated Architecture Builder start page. When you first bring up Integrated Architecture Builder, the start page not only has the links for creating a new project or opening an existing project, but it also has a lot of different learning tools and sample projects that are available for you to look at. So going from left to right here, the first thing I want to cover is sample project. When I click on this, it actually brings up a bunch of projects that Rockwell pre-built to use as a launching point. So again, if I went to ControlLogix, for example, you can see that there's these different ControlLogix architectures that were pre-built for you, and you can just, by selecting one of them, it'll actually load that project and give you a starting point. So if I click on this one, which is integrated motion in a linear topology, and I click on the network tab, you can see here a ControlLogix system. It was added to a linear network with a PowerFlex drive and some Kinetics drives, I/O panel views, and so forth. So it gives you kind of a starting point to work with if you want. Again, these are just examples that were loaded into IAB. Now I'm going to go back to the start page. The next thing I wanted to show you is release notes under Explore. So when you click on release notes, it'll show you what the latest revision is and what was added during those latest revisions. So there's obviously more products. It could be new features, functionality. For example, this new product line, Micro 870, there's some new catalog numbers that were added that support DNP3. So if you're ever kind of curious what was added to IAB since the last update, you can go to release notes to see that information. System requirements. Again, this is more of a utility to make sure your PC has the appropriate resources and hardware. So again, this gives you an idea of what Rockwell highly recommends you use for a PC when you're using Integrated Architecture Builder. And then about IAB will tell you what current version is installed. They'll tell you what it is. You have a website link and technical support. Usually you could start with Revere Electric, your local distributor, when you have questions about it. We have a lot of people trained up on this software, so one of us can help you out. Now under Learn, you have labs and online videos and quick starts and so forth. So if I click on labs, there's all these different labs that are already built, that have been built up over the years, and these can be used as a starting point and a reference for you to get started. You can see they also include like a duration. So again, they time people when they actually developed the labs and read through them, and they kind of found that these are kind of the average times it was taking. So this is an option that's available to you. Or if you like watching videos instead, there's these online videos that again will show you things like, again, these are the different view tabs. They show you like how to use the different wizards. They'll show you how to use certain tools like the Ethernet IP capacity wizard and so forth. So again, they got these videos too that are available to help you out. And then they also have these quick starts, which again are just abbreviated documents. So they don't take nearly as long to read, but they have information that's very valuable in getting started. So again, if you would rather read up on how to do certain things, you go to the start page and go to the learn column, and you'll find all the information you need. Today's video will show you how to use Integrated Architecture Builder to develop a project. We're going to start out by running Integrated Architecture Builder. When this message comes up, I usually hit yes in order to make sure that my software has all the latest updates. And we'll start by creating a new project. Now there's all these different options available, but we're going to start with a blank slate and work our way through it. So this is what the interface should look like when you first start. And before we go into too much here, I want just to point out a few different things. Along the bottom here are some of the main view tabs. This first tab is basically a grouping or a library of different manuals for the different hardware products. The second tab is called Architecture View, and I'll come back to this later. This allows me to divide up our system by enclosures, and just to make it a little more easy for people to visualize where things are located. The hardware tab will work a lot in. This is where we're going to be actually selecting components and bringing them into the project. Then the next tab is called Network, and this tab will bring up the network view that we have. The fifth tab from the left is called On Machine, and this tab will allow us to view on machine type systems. And the last tab is called Wizard View. And in the Wizard View, this gives us the ability to look at and select one of the wizards that are available that we'll talk about later in a different video. To start out though with a blank slate, I usually like starting with the hardware tab. And most of all of the options that are available to us are going to be under Action. So if we go up to Action up above and choose Add New Hardware, we're going to get this selection box that comes up with all the different products that are available. Starting with the controller is usually the easiest thing to do. So if I were to select a 5380 L3, I would highlight this and hit OK. Then you'll have this beginning of a rack, and now down below there's something called the device list. So down here we would go and to the 5380 L3 controllers if we want a standard controller. If we want a safety rated controller, there will be a 5380 L3 compact guard logics. So let's, for our project, let's select one of those. As you look here, you're going to see their different models are shown, and the information about each model is shown over on the right. It'll tell you the memory size, it'll tell you, in this case, what SIL level it meets, the number of Ethernet nodes that it supports, and this last number happens to be the number of local I/O cards that it supports. One nice thing that they've added is Rockwell actually is adding product dimensions. So as we build our rack, it'll give you what the rack dimensions are so that you'll know what the footprint looks like. Now, in this situation, I want to pick the L306 is basically the smallest memory option. So I'm going to pick something that's a little larger because I know I'm going to have more Ethernet nodes, or I know I have more than 8 I/O cards. So let's just choose an L320 like this. Now, this particular model, the L320 ERMS2, this particular model, when you see M in the part number, that means it's going to be able to support SIP motion. And then the S2 stands for a SIL2 safety controller. What's nice with these newer GuardLogix controllers is I can pick ones that support motion and ones that do not. So in my particular example, I'm going to say I don't have motion. So I'm going to choose this ERS2 because my project requires SIL2 and I don't require motion. If I require SIL3, you can see there are processors that have SIL3 ratings. But for our example, we will choose the SIL2. So when I left mouse click and hold my mouse down, I can physically drag up the processor to slot 0 and release. Now at this point, the processor's in. And if I know I have, let's just say 10 slots, I'm going to right click and go to Configure Chassis and change the number of slots. Okay. Now if I did have like an L306 in here and I tried to make 10 slots, it would actually stop me, the software. So I'll show that to you just because it's just to show that this is a rules-based system. So I'm going to do that quick just to show you what happens. So you can see here when I tried to add more slots, the maximum number showing is 8. So if I hit OK, you can see that it kicked my slot number count down to what the limit is for this. Now if I remove this module by right-clicking and choosing Remove Module, I can get rid of the processor, and I'll go back to choose the L310. Oh, the 320 I mean, I'm sorry. Once this is done, I can just close my processor selection, and if I go down a little further, you'll find I/O modules and then 5069 compact I/O. Now, if I were to choose 1769, for example, I'm going to choose that quick because, again, just to show you that the software is going to prevent you from doing stuff. So if I just took the 1769 card, see I'm left mouse holding and dragging, but you can see it's not letting me add it to the rack because it's a different I/O platform that's not compatible with this in the local rack. So if I go to 5069 in I/O modules and go to digital, now I can see the listing of all my 5069 cards. Let's choose an IB16, drag it up. Again, I'm left mouse click and hold and drag. Let's say I have a couple of those, and then let's close the inputs. Let's add a couple outputs. Drag like this. Let's add a couple analog cards. I'll put an IF8 in. Put an OF8 in. Now watch what happens when I add some digital I/O, but they're AC I/O. So I'm going to drag an AC module next to a DC module. Now IAB software will automatically put the field power distribution unit in, and that basically blocks, there's the DC bus, it actually provides isolation from the AC bus so that the AC cards don't damage the DC cards. Okay, and you can do the same thing with the output. So if I chose an OA16, drag it up, there you go. So that's how you build a compact Logix using the freeform method. Now if I click on the overall system, it looks like the dimensions don't show up here, but they will show up in the report that I'll show you later how to do. Okay. So this is the beginning of our rack. The next step is going to be adding a network. So again, if we go up to Action and say Add New Network, we'll simply choose Ethernet IP. And by default, Rockwell has the Converged Plant-Wide Ethernet Layout Wizard selected. But for our project, since we're just doing a freeform, we're going to just start with a standard Ethernet IP. We're going to choose a standalone switch. There are options for device level ring, linear, or freeform, but we'll stick with switch and hit OK. Now the view kicks over to the Network tab, and you can see we have a default switch. If I hit the slide, move the slider to the right up there, I can see the graphics a little better. When I click on it, it starts with a 10-port Stratix 5700. This particular one has full software and precision time protocol and NAT. It may be more horsepower than you need, but it's better to start with a switch that can do pretty much any application versus starting out with a switch that has minimal functionality. Now going back, the way to connect the compact logics to the switch, one way to do it is to go to the tab called Hardware, and you can right click on the processor. Now because this compact Guard Logix has 2 Ethernet ports, you can actually define what mode you want to use. So here you have device level ring mode, where they both ports have the same IP address, or you can say multiple IP addresses in the dual IP mode. So I'm going to select that first. Then I'm going to right click on the processor again and say connect to Ethernet IP network. Now you can see there's A1 and A2, so I can choose which port I want to connect. And then when you see Ethernet IP 001, that's the network that you just created. And since there's only one switch, it's only going to show one switch in the interface. Then you're going to see a connection as long as this is clicked. So you can see how I can hide that. By default, I believe it's on so that you can see that a connection is made. Okay. So now if I go back to the Network tab, you're going to see your processor connected to the switch. Now the next thing we can do is let's add an operator interface. So down below here, we're still on the Ethernet IP tab, and if we scroll down, you're going to find a subgroup called Computers and Operator Interface. So I'm going to expand that and expand the graphic terminals. If I want a panel view 5000, I'm going to expand this, and then I'll expand the 5510. That's what I want to use. And then from here, I can choose from this list. I'll choose a 10-inch since that's a common size. So when I click on one of these, you can see the description. It'll tell you that this is a 10-inch standard aspect ratio, touch and keypad, because the B stands for both, dual Ethernet, and then it's DC powered. Okay. If I want to touch only, I could choose this one, which starts with a T. I'll choose the B model. Now I can left mouse click and drag up until my switch highlights and release. And as you can see here, now I have a connection to the switch. Okay. Now we can do this for many different products. I can do this for distributed I/O, I can do this for drives, and I could do this for servos, all kinds of things. But for now, let's go and find a drive. So we'll go to drives and motors, and then AC low voltage. And then if we expand compact drives, the 525 is located there. Okay. Now if I expand 525, there's just this generic placeholder. So I'm going to hold left mouse click and drag this up to the switch and release. Now what's cool is you're going to actually see an interface that comes up that's similar to what you see in our Proposal Works tool. So now it asks me to fill out some information. So the voltage class, we'll choose 483 phase. The output current, I'll choose a 3 horsepower. EMC filtering, I'll say no filter. Hit accept. You may see this just for the current updater, and we'll say yes. Now here's our drive. So now we have a drive, a panel view 5000, and our compact logics. Now let's add a distributed I/O rack, because in this rack here we don't have any safety I/O. So why don't I show you this? We can actually add safety I/O to this system, and then I'll show you how you can add a distributed I/O rack. So what I'm going to do is, because the safety I/O is DC powered, let's right click on this OF8 and say insert slot after. And I'm going to do it twice so I get 2 of them. Okay. Then I'm going to go to my digital I/O and inputs for 5069. It actually came right up and moved back into that area, which was nice. And then let's choose the IB8S. This is a safety module input. And then if we go to the digital outs, we can choose the OB-V8S. This is the 8-point safety DC output module, and drag that up. So you can see what's cool with the 5380 compact guard logics is I added standard I/O, digitals, analog I/O standard, safety I/O, and I even have AC I/O, all in the same rack. Okay. Now let's go back to the network tab. Let's just say in this particular example, I do have one remote location where I do have to pick up some gate switches or e-stops on this machine. So what I can do now, might as well show this now, I can actually go into this device list right here, and if I know the part number for the Ethernet adapter, I can simply type it in. So let's just take 5069 AENTR. See how that search field actually just gave me the Ethernet adapter. This is actually a really nice way of doing it, especially if you know the part numbers. It'll save you a lot of time. So I'm going to left drag, and there's our new distributed rack with an Ethernet adapter. Now if I double click on this, you can see there's your adapter, and now it starts out with 3 slots. If I only want 2 slots, I can right click and say configure chassis to drop the number down, or I could say remove an empty slot. Now let's do this search again. We know that the safety input module is an IB8S with 5069 on the front. Left click and hold, drag. There we go. And then let's clear this. If you get to some point like this, you can look and say, oh, this is user devices. I have to be on Ethernet IP. So click back on Ethernet IP. Or you could also click on compact logics because the I/O should be there. So Let's go to 5069, compact I/O, and digital, and let's pick up one of these OB V8S modules. There we go. You can see that the connection's already made because we dragged the Ethernet adapter up already. All right, so let's go back to our network. This is what it looks like now. Now the next thing I wanted to show you is how do we rename things so they look like they make a little more sense than what the generic names here. What I like doing is going to the hardware tab, and then you can just right click on the name up here and say rename. So if we want to call this main control, then if you click on device 1, we can say rename operator interface. Device 2, we can rename this as VFD1. And here we can right click, rename, and we'll just call this remote rack. I know, really imaginative. So now when I go back to my network tab, you'll see that the individual devices have different names now. I should be able to rename the switch, same thing, by doing it right here. If I want to call this main switch, like that. Okay. Now you'll notice there's different colors for the cables. So if you look, there's a little legend down here. Copper 1 gig is dark green. So this particular switch has 2 gigabit ports, and then the remaining Ethernet ports are 10100. So the gray are your copper 100 meg speed ports, and then the dark green is your gigabit ports. If I add more devices to this network, they will be 10100 because I used up both ports for my switch, for these 2 devices that have gigabit ports on them. Now another cool thing people don't know about is that you can duplicate devices if you have multiple of the same. So if I right click on this VFD and say duplicate, if I choose 2, let's just say I have 3 total drives and they're all the same horsepower. I can just say I want 2 more of them. And you can see that it created a total of 3. And I could go back to the hardware tab and I can go in here and rename this, VFD2. And rename this VF33. Okay, and go back to the hardware tab. Network tab, sorry. So now this is what our network looks like. Now once we have the network, the pieces that are plugged into the switch all completed here, the next thing that you typically want to do is kind of adjust your cable links. And the cable types. So what I like doing is right clicking on the switch and say configure switch cabling. Now in industrial cabinets where the controllers there's usually high voltage sources. So again, what I like doing is selecting 600 volt Ethernet cable. So this is under the default tab. So I'm going to select 600 volt. I want shielded cable. I want straight angle. And I could choose any for the jacket color. Number of conductors 8. And then these are my options. So if I highlight this one and say apply to default to all ports, it's going to say do you want to reselect, and I'm going to say yes. And now the Ethernet cables will be the same type. Now if I go to the individual ports, it'll show me what device is connected, and it'll also give me a predefined length in meters. So if this HMI is going to be in its own location further away from the main control enclosure, let's just say it's 20 meters away, I just have to choose 20 right here. And then, you just kind of go through, all right, this is going to be in the same enclosure as the controller. So I'll leave that at 2. I'll leave that one at 2. This one at 2. This will be 2. And this remote rack, let's just say this is going to be out 20 meters as well. This will be by the HMI. And we'll hit OK. Now if you want to see the lengths, you just go to UI options and choose SIP and cable information. And then it's going to show you the lengths. So here's a 20, the 20, and all the others are 2. Now you noticed when I put my mouse over the green square, it also shows you like the packets per second and what the network utilization looks like. It tells you it's like part of VLAN 2. So again, just gives you an idea of what's happening from a speed perspective based on default values. If I want to look at other things like the IP address, I can click on this and you can see that the VLAN shows up along with the IP addresses. Node numbers really comes into play when I'm using device level ring or linear topologies. I have this filter for filtering different VLANs. Okay. Now under here, under manage, if I want, I can go into here for VLANs and I can edit what subnet is associated with VLAN 2. So if I highlight it and hit edit, if I wanted to make the IP address 10.10.2.0 is my network address, I could do that. Or if I want to start with VLAN 20 and then, I want to make my third octet match the VLAN, I could do this. And when I hit OK, now it's called VLAN 20. And I just changed the IP address in VLAN to match the schema that I want. Okay. Now you can go into here too and change the IP address if you want. So if I right click on the device and say change address, I can change it if I don't want it to be 5. If I want it to be 2 or 10, I can choose and make those changes right there. Now that I've showed how to change the IP addresses and change VLAN numbers, another thing I wanted to show you was how you can do things with reporting. So under info, if I go to report here, this will give you a listing of each of the devices and what they're connected to, and again some of that utilization and packet per second information for each device. So for example here, the operator interface, this port is tied to port 1 and this is the information coming from it. You can see the VFDs, the main controller, and so forth. Okay, so again, this is a nice little report that gets created for you. Now the next thing I wanted to show you was how to use the architecture view. So if I go to the architecture view tab, you can see it looks somewhat similar, right? But now what I can do is I can kind of group things. So if the main control, the main switch are in the same cabinet, right? We can kind of, and then same with the drives. We could do some organizational changes here where we do something like this. And then, if we want to make whatever way you want. And if we hit this add enclosure, now I can drag a box around here to show you what's in enclosure 1. And then if I want, I can drag now that I have enclosure 2 built, you can see how we can use the architecture view to, again, kind of make it easier for engineering or sales or the customer for that matter, kind of see where things sit. Now another thing I wanted to show you is how you can actually add auxiliary items like power supplies to the system and see if you have enough current to power up a particular system. So here what I'm going to do is, you can see on the right there's control power status and field power status, and you can see that they're not being satisfied, so they're showing up in red. So to start with control power, up along the top you can see this power supply called control power supply wizard. When I click on this, it'll show you the power supply options along the top, and it'll show you items that need power down here. Okay, so if I wanted to start with this 5 amp power supply, I can hit add, and then if I want that power supply to be for my controller, I would highlight my controller and hit the arrow. Now you can see it says it's not compatible. So what I have to do now is remove this power supply, and I have to look for one that is supportable. Let's try this one. Alright, so this one, it did go through and work. And since the switch is in the same cabinet, let's try to put that under that power supply. Now I'm at 25%. Now if I need another power supply in that remote rack, let's add a 5 amp for that one. And if I highlight this power supply, you can see I added those 2 devices in, and that gave me adequate power for those 2. Now if I hit OK, don't worry if you still see this red. What I found is that it just doesn't refresh, but if I click off of it and then click back, you can see that it refreshed. So just a minor bug that needs to be addressed in a future release. Now we can go and look. So if we go to the operator interface, you can see that shows that that's been satisfied. Obviously the VFDs don't need anything, and the remote rack says control power is satisfied. So if we go back to main control, let's do the field power wizard next. Okay, so here if I go to chassis specific, these are your IO cards. It's set to 50% of maximum power, and then this is the sensor actuator power plug on the processor itself. So I'm going to choose the XLE. I want a 240E, which is the 10 amp. Start just adding all the modules underneath it. Okay. And again, if I click off of here and click back, you can see field power is satisfied. So now at this point, now our power supplies are taken care of. Now you may be asking, why do I need 2 separate power supplies for the processor? Okay, you can see two of them here. On the processor, there is a plug on the top that's called mod. That's short for module, and that powers the processor circuitry and then the circuitry of each of the I/O cards. And then there's down here, there is a terminal block which says SA for sensor actuator, and that's a separate power bus that runs along the bottom of the cards. And again, this, if you have a separate power supply for field power and you lose the field power, if you still have a separate power supply for the modules, then you can utilize the diagnostics on the compact logics to tell you something's wrong with field power. So it's better to have two power supplies so that if you lose one power supply, you just don't lose the whole processor. So that's the reasoning behind that. Can you use one power supply for everything? The answer is yes. You can run one power supply into both terminal plugs, but again, if you lose that one power supply, you lose any diagnostic capabilities of the controller or the I/O cards by doing that. Okay, so now we have a compact logic system. We have the field and control power figured out. We have our operator interface and some drives and a remote rack. Now at this point, if you want, you can save the project. We can go here and see what the project BOM looks like. You will see some legalese, basically saying this is a tool that still requires, obviously, it to be reviewed. And then when I hit OK, it says there's 2 warnings present and then 9 informational messages. So if we say visit project checker here, let's see what the warning is. Okay. This is a common error I see with safety I/O. Basically what it says here is that safety I/O, that IAB doesn't allow for 2 RPI values with safety I/O. So what it does is it uses the faster of the 2 RPI values in the communication details. So this is a common thing, basically saying, hey, it's more of a warning thing that there's 2 RPI values, but we're only going to use the faster of the 2 in our calculations. Very common, been there for a long time. All right, so once that's done, again, if I go back to look at the bill of material, this time I kind of know what the project checker says, so I'm going to say continue generation. And it's going to give me a list of the hardware and the software. So if I let it wait, it's going to select some software for me too, if it's needed. So now it's showing me all the parts for the hardware with the remote rack, the operator interface. Again, all these prices are list, so take that into account. And then here it's giving me Studio 5000 part numbers for the safety editor, and it's giving you both the part number for the electronic and the media. You only need one of those. It's going to give you both. And then it's giving you the part number for a subscription for the software. Then it's giving you, again, RS Networks bundle if you want it. So it's giving you like all these different software options, and you can choose whether you want them or not. In fact, your Talk Network Manager is used, to manage multiple Stratix switches, or even one for that matter. So at that point, what I can do is I can say save to a spreadsheet, or I can choose organize where it's broken out by area, or I can hit consolidated if you just want to see it all at once. It's up to you. Okay, so that's how you can, and again, all the prices you see are list. So you can create that spreadsheet, send it to us, and we'd be happy to fill it out with what your pricing is and provide a quote. Okay, so we've gone through setting up what the controller would look like. We put an operator interface in. We chose some drives. I think this is pretty much where we end. So we will just pause here and for a Q&A session. Thank you.